Bismillahirrahmanirrahim. In this video, we learn about Wye-Delta systems. And let's see the circuit. You can see that the source is Y connected or star connected, and the load is delta connected. Now, one point we have to keep in mind that whenever we want to calculate or load, then we have to look toward, calculate the voltage, then we have to look towards the source. And if you see here, this is one phase voltage, this is second phase voltage, this is third phase voltage. So, like VAN is one of the phase, and to easily understand, we write it as VP, which is our domestic voltage in our home. In our country, it is 230 volt. So that is phase voltage. And now the line voltage is actually line to line voltage. So between line to line, this is line voltage, and this we'll write is VAB. So this A and this B, and this is approximately 400 volts, which we'll see how this comes, 400 volts. So these were the two voltages, and now for the current we look toward the load side. So we'll look here, and here we can see that the phase current is IAB, and actually the phase current is through any one load. So any current through only one load is the phase current. So this is IAB is the phase current, and similarly IBC and ICA. And the line current is the current flowing through the main line. So like this is IA, this is IB, and this is IC. Now phase voltage for the positive sequence case can be written as VP0 is one of the voltage, the other is VP minus 120, and the third is VP plus 120 or minus 240, same thing. So these are the phase voltages. Now from here we can directly get the line voltage if we remember this formula. You know the line voltage will be more than the phase, so we multiply it by under root 3, and we just add an angle 30 degree with it. So using this formula we can find the three line voltages, that is VAB is under root 3 VP 30, then VBC under root 3 VP 90, and VCA is under root 3 VP minus 120, or you could have just added 180 with this, so that will make 210 positive, not 180, I'm sorry. You add 120 plus 120, so it would be plus 150. So minus 210 or plus 150 is the same thing. If you add 360 with this, it will give you 150 plus 150. Okay, now in this case, this voltage VAB is also equal to this voltage VAB. So that is why it is written VAB, VC, VCA, but this is not always true. Like if there was an impedance here, then we cannot write that VAB is equal to this voltage, because there will be some drop here. So keep in mind that. Okay, and if we know this voltage VAB, then directly we can calculate the phase current, because voltage divided by impedance, so VAB divided by delta is IAB, phase current, and similarly the other two. And line current can be calculated two ways. One is that we write the formula at this node, that line current is equal to IAB minus ICA, and this you can use all three to find the value of the three currents. But there is, we'll apply the simple technique, that is of this. That is line current is under root 3 phase current and minus 30. It's similar to this, except that the angle is minus now. And so by applying that, we get the three line currents as shown here. Okay, now let's do 12.3. For a balanced ABC sequence, Y connected, with VAN 100 volts. So the source is Y connected and delta connected load 8 plus J4. So these are the delta connected loads. We have to calculate the phase and line currents. So we'll follow the simple technique. We will, let's see, these are the two things given, the voltage of, I'm just talking of one phase, VAN, and one delta this. So we'll convert this delta into star. So that will make our life very simple, very easy. And to convert delta into star, we simply divide by 3. So this is ZY. Redrawing this circuit, our circuit will look something like this. So VAN and this is ZY. We cut this one portion. So this is our simplest circuit for one phase. And from here we can easily calculate the current, which is the line current. So this voltage divided by this impedance will give us the line current IA. So line current is 33.54 minus 16.56. So we have calculated one line current, and the other two can be just by changing the angle we can calculate the other two. So IB will be IA minus 120. So we just add minus 120 or 1. So this will be the answer, and the IC will be IA plus 120 or minus 240. And by solving here, you get this angle 33.53. So these are the three line currents. And now we'll just apply the formula to get the phase current. This was the line current. From here we can calculate the phase current to be line current divided by 3 under root 30. We have these three line currents. So from here, straight away applying the formula, we can calculate the three phase currents. Okay, now let's solve the practice problem. Similar but slightly interesting. One line voltage of a balanced Y source is VAB 120. So keep in mind this is capital AB, not this one, not this one. Capital AB is saying. So we'll just go into this, that the voltage across is 120 minus 20. However, if he would have mentioned V small ab, it will be still same, the same voltage here. So we know this voltage VAB, we know this impedance, so we straight away can calculate the phase current IAB. So using this formula, we can calculate the IAB, VAB divided by Z. So this is IAB, and the other two phases will just simply calculate by varying the angle. So first one with minus 120 and the second one with plus 120. So we get these three phase currents. And now the line current, simple, the same formula. Line current is equal to under root 3 phase current angle minus 30. And just plugging in, we can find the three line currents. So I hope this gives you an understanding how you can solve these problems. These are very, very simple problems. Thank you. And this is the answer given in the book. So they are similar except for some variation, like here it is, we have got minus 20, minus 210, he has got 150. So if we just add 360, it will become 150. So they are the same answer, no difference. We can add 360 with any angle.